All right, we're going to continue our unit on right triangles and similarity as we talk about inverse trig functions today. We talked about the trig ratios, and hopefully you remember the SOHCAHTOA. I put a catchy little song on the website to help you remember that phrase. But if you can remember that, that'll help you in trigonometry. So SOHCAHTOA, sine equals opposite over hypotenuse, cosine equals adjacent over hypotenuse, tangent equals opposite over adjacent. We're going to work the inverse of those functions to help us find measures of angles in right triangles. So just to review, let's say we're solving an equation, 3 times x equals 21. I need to get x by itself. So in order to do that, x is being multiplied by 3, so I need to do the inverse of the multiplication function. So I divide by 3 on both sides. And I would get x equals 7. Same way, if I had x plus 3 equals 12, in order to get x by itself here, I'm adding 3. I need to do the inverse of adding, which is subtracting. So I subtract 3 on both sides of the equation and get x equals 9. When I take x squared equals 16, well, the inverse of squaring is taking the square root. So I take the square root of both sides, and x is equal to plus or minus 4. So that's what we're doing today, is finding the inverse. So let's say I have the tangent of an angle equals 0.75. Well, if I want to figure out what that angle is, I need to get that by itself. So I need to do the inverse of tan, which we just call the inverse. We don't have a fancy name for it. So tangent inverse. So I take the tangent inverse of 0.75. That'll give me the measure of angle A. So measure of angle A will equal the tangent inverse of 0.75. I'll show you how we do that on our calculator. On our calculator, first of all, you just want to make sure that we're set on degrees. So make sure your calculator's in degrees mode. And once that's set, we just type tangent inverse, so second tan. So I have tangent inverse of 0.75 because I'm finding which angle gives me a tangent ratio of 0.75. And it calculates and says, well, that angle would be 36.9 degrees. So I would say, well, angle A is approximately 36.9 degrees. Okay, so that's the basics of what we're doing. Let's now talk about how we use those now. So here's a chart that's in your notes. It tells us, so this chart tells us how we use inverse tangent, inverse sine, and inverse cosine. So each of these trig ratios, tan, sine, cosine, each have an inverse if we want to find the angle measure of that given ratio. So for instance, if I want to find the measure of angle A to the nearest tenth of a degree, I look at angle A, look at what sides I have. I have the opposite side and the adjacent side. So I would say, well, the tan of A equals opposite over adjacent, 15 over 20. Now I could simplify that if I wanted, and I could say, well, the tan of A equals 3/4, but I want to find out what A is to the nearest tenth. So I'm going to have to get rid of tan, so I do the tangent inverse, which will eliminate tan over here, and I take the tan inverse of 3/4. So A be equal to the tangent inverse of 3/4. So you go to your calculator and you do tan inverse of 3/4, and we get 36.9. Notice it's the same as that decimal we had before because those are equivalent. So we would say our solution, measure of A, whoops, forgot to finish that. So this was 3/4. And so measure of A would be about 36.9 degrees. Okay, so that's how we can find an angle measurement when we are given two of the sides. So let's work with the inverse sine and inverse cosine. So here sine of A equals 0.87. Keep in mind this only works in right triangles. So I'm going to do the sine inverse to get A by itself. So sine inverse of 0.87. So A will be equal to the sine inverse of 0.87. And same with B. I've got the cosine of B equals 15, so I'll do the cosine inverse to get B by itself. And I've got the cosine inverse of 15, or 0.15 rather. So we'll go to our calculators and we will compute these. So sine inverse of 0.87 gives us 60.5. So A is about 60.5 degrees. And then cosine inverse of 0.15 will give us, what is that, 81.4 degrees. So B would be 81.4 degrees in that situation. So that's how you use your calculator to help you find sine inverse, cosine inverse, or tangent inverse. So here's how we can apply this for a triangle. So we want to find out all the missing side lengths, taking what we know about trigonometry. So first of all, based off of anything, I know I've got a right angle of 35 degrees, which means this one has to be 55 degrees, angle A, because the three angles add up to 180. Now I need to find BC. So I can use either angle. I'm going to start up here and look down. Here's my opposite side, and this will be my adjacent side. Remember, the adjacent is the one shared. Well, this one would be my hypotenuse because its hypotenuse is always across from the right angle. So I've got opposite adjacent, SOHCAHTOA. So tan of 55 degrees equals opposite over adjacent. So to solve that, I would take the tangent of 55, and then I'm going to multiply that by 14 to get my value of x. So 14 times the tangent of 55 degrees gives me 19.99, so about 20. So we'll say x equals 20.0. So this is 20.0. Now there are multiple ways that I can get that third side. Since it's a right triangle, one way is I could say a squared plus b squared equals c squared. So 14 squared plus 20 squared equals c squared. So 14 squared is 196 plus 400 equals c squared. Add those up, I get 596 equals c squared. And then I would take the square root of that. So square root of 596 is c squared, or equals c rather. So then I could approximate it by taking the square root of 596, and it's about 24.4. So that measurement would be about 24.4 units. Okay, so that's how I can find out all the other measurements. Those are just one way that I could do that. Let's take a look at this next problem and figure out what we need to do to solve it. So in this problem, taking what we know about the angle sum of a triangle, we can figure out the missing angle. Then use trig to figure out the second side, and then Pythagorean theorem to figure out the third side. So we're using all the tools in our tool belt. Here we're just given two sides and one angle. So we're going to have to use some inverse trig to find angle A or angle B. So I'm going to start off with angle B. This is my opposite side. This is my hypotenuse. So SOHCAHTOA. So the sine of B equals opposite 20 over hypotenuse 38. Okay, so now if I want to find the measure of B, how do I get rid of sine? Well, I got to do the sine inverse. And sine inverse of my ratio on the right side of the equation. So B, make that a better B, B equals sine inverse of 20 over 38. And then we'll use our calculator to figure out that measurement. So sine inverse of 20 over 38. Notice we don't need to simplify our fraction. We can if we want, or we can change it to a decimal. So B would be 31.8 degrees. And if we're going to round to the nearest degree, we would say that's 32 degrees. So if B is 32 degrees, that would make angle A, which I could use some trig to find that one if I wanted to. And I'll just do that to show you how that works. Otherwise, you know that it should be, well, 32 plus 58 plus 90 gives me 180. So I know it should be 58. But why don't we set up an equation to solve that using some trig so that we know how to do that. So if I'm looking at angle A, I'll get a different pen color here. Angle A, I know my adjacent side and my hypotenuse. So that's going to be SOCA. So cosine of 58 will equal, whoops, I don't know it's 58 yet. Cosine of A equals adjacent 20 over hypotenuse 38. So in order to get A by itself, I do the cosine inverse. So cosine inverse of 20 over 38 should give me A. And I can calculate that. So cosine inverse of 20 over 38 gives me 58.2. And that looks like it agrees with what we had before. So notice that you can take any method that you've learned, just apply the one that works simplest and easiest for you. And then we can find the third side by way of either Pythagorean theorem, or we could use some trig again. Since I showed Pythagorean theorem earlier, I'll use trig this time. So let's say we want to find this third side. Let's look at this angle here. This would be the opposite side from 58. And I'll use my hypotenuse. Since I have that side, I could also use this side as well, but I'll use hypotenuse. So OH, so sine of, since I know it's 58 degrees, I know that's equal to opposite, which I don't know, over hypotenuse, which is 38. So if I multiply by 38, 38 times the sine of 58 will give me O, my opposite side. And once again, we'll consult our calculator. Calculators are very handy in this lesson. 38 times the sine of 58 gives me 32.2. So O would be 32.2, or just 32 if we're going to the nearest whole number. Okay, so hopefully you learned some inverse trig, and we know how to use that on our calculator to find the missing angle when we know the ratio. We'll do some practice, and if you have questions, we can always take those in class.